Okay, function analysis. Answer the question or help us think about the question, what do f prime, first derivative, and f double prime tell us about the graph of f? So that's the big picture. Like this is unit 5. I guess that's a question mark. That's this unit in one statement right there, or one question. What do f prime, the first derivative, and f double prime, the second derivative, tell us about the graph? Today is only going to be what does f prime tell us about the graph. Tomorrow we'll talk about what does f double prime tell us about the graph. And today we kind of know about what f prime tells us, because what does the derivative tell us? The slope. So we kind of know today's answer. Tomorrow we'll worry about second derivative. But if you know that f prime tells you slope, like there's a lot of notes today, but it all comes from the fact that f prime tells you the slope. So if we already know that f prime tells us the slope, I feel like today's a pretty straightforward day, even though it's like, oh, that's a lot of stuff there. But it all relates to the fact that the first derivative tells you the slope. Okay, basics of reading a graph. Always read a graph like you read a book, left to right. So when we say, does the function go from positive to negative, we're asking that as we move left to right, does the y value change from positive to negative? Okay. Writer, need you focus in, okay? Read a graph left to right. Only consider the domain of the function. So if we're asking a question, you don't have to worry about the part that's not in the graph. This is kind of weird. It sort of is understood and it doesn't really come up. But you don't have to say, well, it doesn't exist over there, so how do I answer that? You only have to worry about where the graph exists. Yeah. Whatever the opposite of red stars is what you put on that. Like, that doesn't matter so much. So I don't know how to indicate that. The opposite of boxing and highlighting. The graph below is assumed to continue forever in both directions because there are no designated points at its end. The lack of arrows is insignificant. The arrows are implied. Okay, that's important as we move forward. Like, you assume it keeps going unless there are points that say, no, we stop here. Okay, as x moves to the right, if the function is going up, the function is said to be, want to guess what word goes there? As we move left to right, if the function is going up, what is the function doing? You're just guessing at a blank at this point. What is that graph doing right here? Increasing. As we move left to right, the function is increasing. I'll write that one more time. Read left to right. Always read a graph like you read a book, left to right. As x moves to the right, if the function is going down, so as we move to the right, if the function's going down, then we would be decreasing. All right, we're going to need 2 highlighter colors. It doesn't matter which 2 you use, so feel free to share with a friend. I've got some I can share as well. In fact, I've got a bunch up here today that I can share. So I'm saving 2 for myself. Would anyone like to borrow a highlighter? Anyone else? Just gives me a chance to throw markers around the room. Anyone else? And you'll need 2, so as long as you and your neighbor have 2, then you can share back and forth. No one else wants me to throw highlighters around the room? Okay, so pick whatever your increasing color is going to be. I'm going to go yellow, but it doesn't matter. Like, pick your color here for your increasing color. So we're going to highlight the increasing areas. So left to right, as I move left to right, if I'm going up, I'm increasing. Going up, I'm increasing. Increasing, increasing, increasing. Might look weird because you're not using yellow, but all the increasing spots, all the moving up left to right, put those in one color. And then pick your different color for the decreasing spots. Going down, going down, going down. Done with highlighting for a little bit, but if you borrowed one of mine, keep it. That way you may use it later. Quick side note here that people mess this one up pretty frequently. Is this graph increasing or decreasing? All I heard was the creasing. Oh, now I heard it separate. I heard an N and a D on that one. You got to move it left to right. Wait, yeah, left to right. So it's increasing. That would be an increasing graph. And that one's hard because your brain and your eyes see the point and see it going down, but it's going down like the opposite way. As we move left to right, that's an increasing graph. All right, relative extrema visually. I guess first, relative means relative to its neighbors. Another word for relative is local. So a local extrema, a relative extrema, just means it's at the top of a hill or the bottom of a valley. But it doesn't mean it's the highest mountain in the range. It just means it's the top of, relative to his neighbors, he's at the top of the mountain or the bottom of a valley. Okay, this sounds fancy here. There is an interval, a neighborhood, an area, around the point A, comma, f of A, and you see that point's on our graph up there, at which f of A is the largest value of f. That makes f have a relative maximum. He's the top of the hill. Doesn't matter if it's the highest hill, he's at the top of the hill, so relatively speaking, locally speaking, that's a maximum. The value is f of A. The location is at x equals a. It's sort of the what is the value versus where is the value. What is the value is the y value, where is the value is the x value. I already used the word local, but another phrase for this is local maximum or local max. Local max, relative max, we use those interchangeably. There is an interval around the point B, comma, f of B. So, what do you think we would call that point? Relative minimum. Relative minimum. The value is f of b. The location is at x equals b. And a lot of times we'll abbreviate max and min. What about that point C, F of C? Is he at the top of a mountain or the bottom of a valley? Like, is there a neighborhood where he's the lowest point? Yeah, so that's a yes. That is a local minimum. So I guess the key question we're talking here is, can a cusp be a relative max or min? Yeah, it can, because that just happens. Yes. Just a little vocabulary here, or how to plural. Relative extrema are either relative maxima or minima. Extrema is the plural of extremum. So extrema includes all of the maxes and all of the mins. Consider the graph y equals f of x shown below on the interval a to b. This is the same picture that we were just looking at. By the way, if you peek ahead, you'll see that picture a lot. We'll do a lot with that picture. How many relative maximums does that have? What do you think? How many relative maxes does that have? How many tops of mountains are there? I think I heard it. 1, 2, 3, 4. So 4 mountaintops. How many, Braden?
Guess you don't like the starting and things.
That's tricky. You're right. Let's see. You don't count the endpoints. That's why I'll use the phrase, I know that's, yeah, you're like, well, in its neighborhood, but that's why I like to use the phrase the top of a mountain, because a mountain sort of implies that there's two sides to it, I guess. So we don't include the endpoints. That's a good question. How about relative minimums? How many bottoms of valleys are there? 1, 2, 3, 4, 5. Should be careful with that middle one. That doesn't. I was trying to do slopes of 0, but that middle one, that does not have a slope of 0. But it is a relative minimum. What can you say about the derivative of f at each location of the relative extrema? So at every point we marked, what would you say about the derivative? I almost gave away the answer a little bit here. What would you say about the derivative? It's one of two things, so there's sort of two answers here. It's either f prime is either one thing or another thing. So these flat spots, what is f prime at those places? 0. And what is f prime, even though I drew a flat spot, that wasn't right. What is f prime equal to right here? It's a bit of a trick question. What is f prime at a cusp? Yeah, undefined or D and E. D and E might be better. We use those interchangeably, and that's okay. So every max or min either has a flat spot, f prime equals 0, or a cusp does not exist. So we're just repeating this. F prime is either 0 or undefined. Critical numbers, that's the definition of a critical number, because those are important spots. They're critically important. So F critical numbers are all the spots at which the derivative, at which f prime equals 0 or f prime does not exist. Now, we need to be careful. These are candidates for the locations of relative extrema. So critical numbers are where f prime is 0. See how far I want to go today. We got one more page to go. But they're candidates. So if f prime is 0 or undefined, that doesn't mean that it's definitely a relative max or relative min. Okay, some examples. Find all critical numbers. Again, critical numbers meaning where f prime is 0 or undefined of this thing. So I need to find its derivative first. That looks like a quotient rule problem. Let's pick on people. So it's not always me talking. Caden, what's the derivative of the top? And Graham, the derivative of the bottom? 2x. So my overall derivative, gf prime. Start at the bottom, work your way to the top. Gf prime, keep the gf first. So gf prime minus fg prime all over g squared. Excuse me. Okay, so let's clean up the top a little bit. I think some stuff's going to go away. 2x cubed minus 18x minus 2x cubed over x squared minus 9 squared. So the 2x cubes go away. I'm left with negative 18x over x squared minus 9 squared. Okay, critical numbers. Either g prime is 0 or g prime doesn't exist. And we have to think about both. 90, 95, 98% of the time, the critical numbers are going to come from where g prime equals 0. And so the trick will be, if its g prime doesn't exist, did you even remember to look for it? That's where people make the mistake. Because it's usually the zeros, but you have to look for the DNEs as well. So what would make this derivative, what would make that derivative equal to 0? This is just fraction stuff. Oh, you answered a better question than I was even asking for. If there's a fraction, it's equal to 0 if the top is 0, and it's undefined if the bottom is equal to 0. So negative 18x equals 0 means x equals 0 is one of the critical numbers. Bottom equals 0. That would be one where some people would algebra their way toward the answer. Other people would just look at that and know what x would work to make that be 0. I guess I'll do the algebra way. If we square root both sides and move the 9 over, and then we square root both sides again. Be careful, what do we get when we put plus or minus? That's the potential mistake there. So, 3 critical numbers for that one. One made it 0, 2 of them made it undefined. 2 different critical numbers. Number 2, find all the critical numbers of this thing. This looks more like product rule. So let's see. I'm not going to write them out. I'm going to do first times derivative of the second plus second times derivative of the first. know where that's 0 or undefined. I don't think I'm worried about undefined. That's always going to be defined. E to the x always works. Cosine and sine always work. So that's always going to be something. It's always defined. Let's set it equal to 0. I'll factor out my e to the x. Let's see, it's algebra stuff here. So e to the x equals 0, or cosine x plus sine x equals 0. Do you remember what the graph of e to the x looks like? There's a horizontal tangent line of 0, yes. So where does e to the x equal 0? Nowhere. So nothing from that part of the problem. From this one, I'm going to move the cosine over just so I can... I don't know that I'll be able to solve this algebraically. This is more like thinking about things. Where does sine of x equal negative cosine of x? So what reference angle have the same sine and cosine? Forget about the plus and minus stuff for now. At the over 4s. So I'm definitely looking at the over 4s. But I want them to have a different sign. Or a different SIGN, a different plus or minus. Okay. So that's the second and fourth. So 3 pi over 4 and 7 pi over 4. Where they have the same value, but they're off by an SIGN sign. So those are my critical numbers. So in practice so far, critical numbers is just another way of saying where's the derivative equal to 0. Big picture wise, critical numbers are the possible maxes and mins. Possible maxes and mins. All right. One more page, only 5 minutes, but this is going to go quick. Because increasing and decreasing intervals, we'll just skip to the main point here. Increasing would be where f prime is greater than 0. If the slope is positive, then the graph is increasing. If the slope is negative, then the graph is decreasing. That would be where f prime is less than 0. We can skip this dashed box here. That's not, it's important, but it's kind of be covered already. What can you say about the derivative of f when f is increasing? That means f prime is positive. What can you say when f is decreasing? F prime is negative. The starred box here says the same thing. F is increasing if f prime is positive. F is decreasing if f prime is negative. This is a weird note here. A function can be increasing or decreasing wherein the derivative is undefined. Right? That's that vertical tangent line. The f prime is d and e. But clearly, just looking at the graph, it's increasing. So that doesn't happen often, but it can, so we just need to be careful. Let's see if we can answer one of these before we are done. On what intervals is this graph decreasing? Justify your answer. Okay. On these problems, I always like to justify my answer first, because then I know what I'm looking for. So where is g decreasing? How will I know if g is decreasing? What would I be looking for? Where what is negative? And how do I say slope in a fancy calculus way? The derivative. So g is decreasing when g prime is negative. You need to say all that, and you need to be careful with your g versus g prime. please don't ever say it's negative. We don't ever like it in here because we're always dealing with G or G prime or tomorrow G double prime. So I don't know which one you're talking about when you say it's negative. You got to say G prime is negative if that's what you mean. Okay, so G prime is negative 9x squared plus 6x. Let's figure out where that's 0 first. I'm going to factor out a negative 3x. That leaves 3x minus 2. So x equals 0 or x equals 2/3. Those are my critical points. But I need to know what's happening in between there because I want an interval, not a point. So I'm going to make a number line, and I'm going to test the intervals of G prime. So I'm going to plug in negative 1, something between 0 and 2/3, 1/3, and then maybe 1. If I plug those into G prime, negative 1 won't be too bad. See, that would be negative 9 plus negative 6. That would definitely be negative. You can trust me, it's positive and then negative. And so it's decreasing from negative infinity to 0. That's what we're looking for. Because we're looking for where G prime is negative. And then 2/3 to infinity. Okay, I didn't even write my answer. That's terrible. Negative infinity to 0, 1/3 to infinity. Try only 1 through 8 on worksheet 2. It's only 8 questions, but do try them. It's all about F prime. Tells you whether you're increasing or decreasing.